1, 2, 1, 2. 1, 2. Need to check that you can hear me. 1, 2. Need to check that you can hear me. Yep. 1, 2. Need to check that you can hear me. Yep. Okay, sounds maybe a bit bassy. I'm just going to edit it slightly. 1, 2, 3. 1, 2, 3. Is that better? Slightly. 1, 2, 3. 1, 2, 3. Is that better? Yeah, sounds a bit better. Maybe a bit loud. A bit quiet even. Even. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Oh, that seems better. 1, 2, 3. 1, 2, 3. Oh, that seems better. I'm getting some kind of horrible feedback. That's fine. It's just because I've got this running at the same time. Okay. Let's see. Does anyone come along? What I want to do now is hide this slightly. You can see that. Just give it a few minutes for anyone to come. Content. Let me just see what's going on. Where are we? Okay, it's not there yet. That's fine. Okay, we seem to be getting some things through now. Cool. Okay. Are we still working everywhere? Yes. I think we are. 1, 2. 1, 2, 3. I think it's still possibly a bit quiet, so I'm just going to pump me up a bit. Maybe add a bit of gain. Close. 1, 2, 3. 1, 2, 3. It's very quiet again. Why does this keep happening? 1, 2, 3. 1, 2, 3. 1, 2, 3. Sorry for the technical details. It might just be that I'm talking quietly. Maybe I just need to talk louder. How does this sound? How does this sound? Hello. Talking into the void. Oh, I don't want to type that. The void. Okay, sounds better now. Good. Okay. It's very exciting. I'm very excited. Check out the robot now. Let me see how, so I can see where you can see me. It's my own stream with timepiece therapy. Harry, check it out. So now we have double layer robot, double decker robot, and the reason for that is we've got a LIDAR. You can see it spinning on the top, and it was like, it's basically what it does, it sends a light out, times how long the light comes back, and never heard of her. Lols. Tells how long it takes back, and that tells you how far the distance. So it's much similar to the sound, this one that we were coding the other day, but sound is a much slower than light, and so light, by the time, even though it seems like it's spinning fairly fast, it's still long enough for the light to come back and for the light to go there and come back. And what's cool is if I get it exactly right, although maybe it's not on right at the moment, it's just sort of in its idle state, I think. Let me see. You might be able to see the laser. I can see the laser in the camera. I don't think you can. But, so what this will do, it gives us 360 degrees view of what's around the robot, as opposed to this, which is like a 100-degree view, I think it is. Yeah, something like that. This is 360 degree. So I've already coded it. I've already coded it to. Let me see if I can show you what I've done. The reason why I'm hesitating why this might not work is because it's going to be super small. Documents, LIDAR, web server, text editor. Where is it? Where's my text editor? Here it is. Okay. Let me see if I'm going to zoom in. Zoom, select font. Make it massive. Font size. Select. Okay. It's kind of way too big, but we'll work with it. This is incredibly painful. No, I can't deal with it. I can't deal with it. It's too much. Select font. I think we just need to go down a bit. Maybe like 36. Okay, fine. Okay, so we connect to the LIDAR. I've written a class. I'm not going to. Well, there's a class I found online that basically does all the hard work for you. So all you do is connect to and start the scan, and then I start a little web server, listen to ports, get the request, get the URL, blah 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 blah, and all I'm doing. So what you can do with the LIDAR, you can get all 360 degrees, or you can get them in batches of like or you can split it into 40 and get the highest value from the sort of batch of 40 degrees, if that makes any sense. Or you can do 20. It's kind of like, think of it as like a lower resolution, so you don't have to pass so many variables. So I've made that as a variable in the API, so you can specify if you want chunks 40 or 20, but if not, you just get the whole data, dump that in JSON and return it. So here on my actual computer, what I'm doing is requesting that JSON and then using some clever maths with trigonometry, working out, converting. So this is what, before we get there, this is what you get. You get a measurement in meters for every degree. So this array has 360 numbers, and each number represents how many meters away a thing is from the robot at that degree. So like that's 0 degrees, 1 degrees, so that's like 2.2 meters, 2.2 meters, 2.2 meters. And you can use maths to make sure that, like, so this, turn it into a basically Cartesian coordinate, and then you can plot it. So let me just hold this up so you can see. Okay, I'm now going to run this script. So this is now going to stop. And what this does is it pings every second. This is warning. Oh, and it broke. Okay, Control Z, Control T, Control T. This like literally worked like a second ago. And when this happens, for reasons I don't quite understand, I just have to kill, it like completely freezes Python. So I just have to kill it. If I go back to here, what's happened with our web server? Has it died? Has this just completely crashed? Can't do anything. Yeah. Okay. Something happens. I need to work out, like, yeah. Okay, it's just broken. Luckily, I have a handy switch. Ugh. I need to make it so I can see what I'm sending to you and the chat. I'll make this over here. Okay, right. There's a handy switch there. So I'm just going to switch it off and the LIDAR will stop spinning. I missed. There we go. You can see now the LIDAR's just completely dead. Just going to give it a minute and click back on. Okay, let's start spinning again. Always works in practice, doesn't it, and never live. Right, I'm just going to close this. So the basic idea today is I want to try and make it move. I want to give it a command, just like move forward, and I want it to stop once it gets within. There's actually like, it can't, if it's too close it can't measure it, so until it can't measure it. I think that will be the idea. So all we're doing now is we're just waiting for the Pi to restart itself. Let's just give it a minute. Hopefully it hasn't corrupted. No, cool. I need to work out why that happens. Basically, if I stop the script and then I restart it again, it like crashes it for some reason. I sort of vaguely know the problem. It's because I'm not streaming, I'm just constantly pinging it, which is not great. You should do like a data stream where it just updates the data rather than having to fetch it every time. Just waiting for this Pi to boot up. So the Pi is in here. It's in there somewhere. It's basically going to get very difficult to debug this now. This double layer, but it looks cool. Look at the LIDAR spinning. Okay, I'm just excited to show you when it actually starts working. Okay, so I'm just going to run the web server. Come on. Why are you taking so long to open a command terminal? And while that's working, let's just check this all looks good. So yeah, so basically I'm turning the angle into a position using maths. Presuming this is trigonometry, I'll copy this from the internet. I haven't actually worked it out. And then I'm plotting it in a graph. Hooray, we've got a terminal. Why is it taking so long to just type CD documents? Yes. CD LIDAR. Yes. Sudo Python web server. Okay, so now that's running. When this runs up, there, you can see that. It's not, you can see the light. There it is. There it is. Look, scanning. Cool. Okay. So now, if I run this, it's going to ping it every second and get. There we go. So now we can see it's getting the readings every every second. You can see them coming in, and if I bring this over here, this is the result of the graph. So it doesn't make much sense now because it's kind of crowded on the table. But if I bring this over here, put it in the hole, I'm just going to hold it in the middle of the room behind me. You can get to see now, look, that is my room. Like over here, there's a door behind me that's open, so you can see that there's the door open. The room goes like that. If I just turn it, you'll see it turn. It's actually quite heavy now. And now the door that was open is over there. Oh, it's heavy. I'm going to hold it down with my arm. If I like just move my hand, I'm just going to hold my hand to the left of it. So you should see it sort of appear like here, I think. Okay, so it's like here. So it's because I'm putting it close. Because I'm putting it close, it's like it's hitting that number. So you can see, look at these are the figures down here, and when it gets 3, what's that number? 32768. That's when it's like basically something's too close and it can't do it. So if I like put my hand in front of it, it basically like the dots would like disappear, and then put my hand back. You can see that corner. So let me do it in front. What I'm going to try and do now, I'm going to just put my hand in front of it, like over here, which presumably is the is the door, or was that me? No idea. But you see how cool that is? Okay, so now I'm just going to put it on the floor. And bring up the control panel. Want a new tab. Why has it done that? Sorry, 1 second. Okay. For some reason this is like always on top, so I'm just going to move it over there. My computer's going mad over there. I don't know, like I think the idea would be 180 control, there we go. So now we've got a video feed of what the camera can see, and we've got like a view of everything around it as well as distance. So if I just hit forward, it's now moving forward. I wish I could show a camera. Okay, so it's something. There's like a thing on the floor. Let me just hit back. I would turn left. No, I wanted to turn right. You can see my messy house now. Where's that thing gone that I tripped over? But you can see, look, there it is. Okay, 1 second, let me just... Okay, right, I'm going to bring it forward. And you can see that, so the LIDAR scan is slowly shifting now. So it is directional, so like this, so 0, 0 is basically the mid, like where the robot is. And so we're slowly getting towards, so what I want to know is, we're slowly getting towards the robot. I want to know at what point do these dots disappear. So if I keep going forward, we're still there. Okay, we're practically at the wall now. Okay, now there's just, it's very confused. It doesn't quite know what's going on. I don't understand quite how that matches what's you can see, so I'm just going to bring it back, and then it's going to be able to scan the room a bit better. It's extremely fast. Oh wait, no, the other thing, slow. Yeah, like, I think we are getting some like random dots. I guess that's because that's like 6 meters to the right of it. I don't think that's quite right. So there is a sort of bit of random noise, and I'm not sure like what this is around here. It might be picking up the cable. It might not be high enough. If I pivot left. But you get the idea. So now, when we're trying to navigate around places, ghost? What's the ghost? Waiting for a ghost jump scare. If I go forward, so yeah, I can see that there is an angle like that. So at what point does that disappear? I can go forward a little bit more. Okay, it's literally hit the door now. The other thing I want to show you, I'm just going to like, if I cover the, no, it's too far. If I cover the camera's like IR sensor, it puts it into night mode, then you can see the scan, the light scanning, which is pretty fun. So I think what we want to do is look at the 0 degree, and if it is less than 100, stop. So I'm just going to stop this now, but when I do that it tends to just break. So let me see, is this going to break? No, I'm also just going to stop this then, because the LIDAR gets very hot, and then we just go grab the robot. And it's mounted on wood, so heat is bad. So we want it to keep going forward. So here's, ideally what we'd do is we'd know how far, we'd take a measurement, take one measurement, know how far that is, know how many seconds we need to go know how many seconds we need to go forward for, and then stop. But I haven't got a mapping from seconds to distance. I don't know how fast it goes, basically, to be able to do that. So I'm going to do it a kind of rubbish way, in that should I still draw the graph? Yeah, let's still draw the graph. And then what I'm going to do is, first point, I'm going to make it go forward. So to make it go forward, you just hit an end point. It's all Wi-Fi controlled, and I can't remember what that end point is. Oh look, this is, oh, has this now stopped? Has this camera stopped working? Yes. Does this mean I've lost connection here? See, why is that? Why is, like, if I stop connecting, it just breaks, and the whole thing breaks? I now don't have, the Pi has lost connection. I thought by doing this it would stop. Yeah, look. There's something funny going on there. So I'm going to have to just stop it and start it again. And give it a few minutes to start up. I can hear the camera. Okay, while that's going, what is the... I've forgotten what the endpoint is to make it go forward. Do 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 do. Where's the script? That is not it. Script. That's the camera. Style. Div class header. Okay, yeah. Control panel. Make request. Where's make request here? Direction, URL. URL. Oh, it's just this /forward. Okay, so one way to find out. Let me just hold this robot up. And stop. Okay, here we go. So do that. So we're going to get the data, we're going to plot the graph, we're going to make it go forward. Toot toot, that's my phone by the way. Make it go forward. I'm going to say if data 0 is greater than 100, then go forward. If data 0 is less than 100, presume it's backwards. Backwards. Backward, hopefully, if I've been good. Okay, it's just going to go back and forward. Backwards. Whoa! Ah! Forgot that actually make it move. Backward. Okay. So if data is greater than 100, go forward. So it's going to keep going. Once it hits 0, okay, we've got a problem. So it's, at the end, this is just going to go like forward, back. What we want it to do is we want it to go backwards until it hits a number, then start going forward. So if the data is bigger than 100, keep going forward. Okay, so we need a flag. Direction is go forward. That's true. Okay. If data, and then I'm just going to say if go forward, do that. Else go back. If 0 is less than 100. So I think what we'll do is we'll do it like this, and then if data Oh, we don't actually need brackets in Python. Is less than 100. Go forward equals false. If data 0 is greater than 300, go forward equals true. So we start with it going true. If data is less than 100, it's going to make it false. It's great. Are we still going to have the same problem? So it's going to say, okay, data's going to be, say it's 200. It's going to go forward. It's going to be 150. It's going to go through. Data 0 is none of those, so it's going to keep going forward. And then it gets to like 90. 90 is less than 100, so it's going to go forced. Change it to false. It's going to go backwards. Then it's going to keep going backwards until it hits 300. Then it's going to go forward. Yes, this works. Okay, big moment. I'm going to have to go put it near a wall, otherwise it's going to take forever. So I'll just run it. And it's not working. Cancel, and it's completely crashed. Hooray! End task. If I go back here, is that because it restarted? I didn't start the web server. Let me just put the robot down. Okay, robots down. CD documents, CD LIDAR, CD web server. Nope. Sudo Python web server. I'm reading it out because I know this is tiny. Okay, I can. The LIDAR's spinning up now. Let's run this. Okay, it's going. Okay, it's just stopping and starting. I should probably show you something. Okay, here we go. Is it going to hit the wall? Yeah. Ah! Okay, it's just trying to climb the wall. Okay, what it's doing is it's going forward, stop. Oh, now it's going continuous. No, forward, stop, forward, stop. Okay, what is the first point? 461, 351, 242. Okay. Okay, I've moved it like really far away now. It's, where's the 0 element? 791. But it's really not. Maybe that's millimeters. Ah, it's hitting the wall again. So this is what it's doing. See, it's like just going and stop. I don't know why it's stopping. Because this command should just keep it going until it gets the next command. Oh, I know why. So every time it's, I see. So basically it's like it's getting the command every second to go forward, and that's making it think again. So I need to, it's a bit annoying. It's like I only need to, it's like I need to, like, if it's changing direction, only send the command. I've got to go in a few minutes. Oh, this is annoying. Got so close. Only if it's changing direction. Okay, and also, like, let's just stop this. Stop this craziness. It's doing my head in. Control C, Control C, Control C, Control C, Control C. So now it's just completely, it's just always going because it's not received a command. And where's my command? The camera's still working. And I just stop. Whew, that was scary. So what needs to happen is it only needs to send the command if there is a change in direction, and also this number's way too small. So let's make this like 400, and then let's make this 1300, and then you know what, I think this flag's no. I think what we need is change direction equals false. I'm typing with one hand whilst holding the robot. I'll put the robot down. It's getting heavy. And then here we're just going to say change direction equals true. And if go forward and change direction, do that. And then if not go forward and change direction, is false and change direction. Why does it hate that? You can write and like this, right? Why does it hate this? Oh, because no idea why it hates that. That should work. Now the question I have now is, did I crash? Oh, the robot's flashing red, it's running out of battery. Is this actually going to work? Was the server dead? The server's dead. Oh no, it's not. Whoa. Okay. Okay. It's still doing its weird steppy thing. No, it's not. It's now going smoothly to the wall. Let me bring up the control. It's now going backwards. It's now going forwards. It's now going backwards. No, it's now going back from the wall. Okay. So once it hits 1,300. Oh, there we go. And now it's going for. It's probably not to show you. Let me just move the camera. There it is, over there. You can see my horrible setup. It's going forward and back. Stop, and then back. Nice. Okay. So, what we've established is, let's just put this over here so you can see it constantly going back. I wonder if you can hear it. I've got noise cancelling going. It is kind of crabbing across the room. I've got a problem where forward is not quite straight. I'm going to have to play with the directions of the speed of the wheels. One of them must be going faster than the other. But it's going back and now it's going forward. It does do a stutter once. I wonder why that is. Every time it's changed direction it stops and then goes again. There. Oh, and here's what it's seeing. forgot this was off screen. Yeah, it could be the wonky wheels. It definitely is the wonky wheels, but I think I could basically I want to fix it in code rather than engineering, because my coding, although terrible, is better than my engineering. So this is what it's seeing. That's so cool. So now I could basically, in the main computer, when someone presses this button, in the logic on the server, I can only let it work if it will check the LIDAR first before allowing the robot to go forward, and the same with backwards. It will only allow the robot to go backwards if there's nothing behind it, and that way it's sort of safe. And the same with like left and right. I can work the way left and right, and I could also work out the width of the robot, whether it will fit. And in this way it's self-driving. Oh, it's so cool watching it go back and forward. It has life. It's alive. The next thing to do is, I might just end there. It's just a short and sweet stream, and the fact that I got it working, I'm pretty happy. Yeah, cool. Successful stream. Thanks for watching, those that did. I hope you vaguely enjoyed yourself, and see you next time. If I can remember how to end a stream. Stop stream.